So we're going to do a review for our exam 1. This will give you an idea how to do some of the questions that you might see on the test. So our first question is, use the given conditions to write an equation of the line. And our first one is passing through these 2 points. So example 1, part A, we have 2 points. We have -4, 3 and -2, -7. So if you need to write the equation of a line, recall that the equation of a line is going to be y minus y1 equals m times x minus x1. And it won't matter which point we choose. I usually will choose the one with a smaller number, so I'll probably choose this one. So that would be our x1 and y1, but we need to know what the m is. So you need another formula. So m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And I'm going to tell you that it's really smart to label your points. I've had many a student that grab the same number twice, or they grab the wrong number. So understanding that it's an xy point for each one, and it doesn't matter which one you put as 1 and which one you put as 2. So we have -7 minus 3, because y sub 2 minus y sub 1, over -2 minus a -4. And make sure you pull all of your negative signs. Well, this double negative on the minus a -4 will make that positive. So -7 minus 3 is going to get us -10 because they're the same sign. So we're going to add and keep the sign. And then we have -2 plus 4, or 4 minus 2, whichever way you want to look at it, is divided by +2. And this will get us -5. So now, over with our problem, we have y minus, and again, I said I would choose this one because the numbers are smaller, so I don't have to deal with the 7. The smaller numbers make the math easier. So y is going to be 3, equal to our slope of -5, times our x minus a -4. So again, bring your negative signs. So this will get us y minus 3, and this, again, will become a +4 because of the double negative. So -5x, and -5 times 4 will get us -20. All right, now we'll add 3 to both sides to solve for y equals -5x minus 17. So on this one, you're going to have to do several steps. On the next problem, we have a passing through this point, but our m is equal to 0. So if m equals 0, that tells us it's a horizontal line. It goes straight across. The slope doesn't change at all. So for a slope equal to 0, this will be part B, we have a horizontal line. And horizontal lines are a y equals. So if we have the point of -4, 3, then our horizontal line will be equal to the y value. So y equals 3 is your answer. On part C, we have it passing through the point of -4, 3, again, and it says our slope is undefined. Well, an undefined slope is a vertical line. So this is going to be vertical, and vertical lines have an x equal. Our value for x is -4. So these you're not going to necessarily plug into the big equation we did for this one. You need to understand. I mean, you could plug in for the slope of 0, but undefined you're not going to be able to plug in because it's undefined. It doesn't have a slope. It's just a straight line. That is vertical. All right, our next problem, number 2, part A, it says to find the domain of the function and write in interval notation. So there's 2 things that we have to worry about with domains. One is can't divide by 0, and the other one is you can't take the square root of a negative number. So on our first problem, where we have g of x is equal to 5x over x minus 7, here we have a denominator, so we're worried about the denominator equaling 0. So you're going to take the denominator, set it equal to 0, and solve. So x equals 0 is what, sorry, that's not 0. X equals 7. X equals 7, I can't add, is what will cause us to equal to 0. I had 0 in my brain there. So if I plug in a 7, I get 7 minus 7 equals 0. Well, that makes this undefined. So that means our domain can be anything but 7. So sometimes the easiest way to do these is with a number line. And I'm going to put the numbers that we need. I don't put a lot because we don't need everything. And it can be everything but 7. So it'll be everything this way and everything that way. So our interval notation will be negative infinity to 7, union with 7 to infinity. And you don't have to draw the number line, but sometimes it makes it easier. All right, our second question was h of x was equal to the square root of 22 minus x. So as we talked about, what we're worried about here is that we will, or we can't, take the square root of a negative number. So I'm going to take 22 minus x and make it greater than or equal to 0, because that means it's going to be equal to 0 or it will be a positive number. And now I'm going to solve for x. So I'll get 22 is greater than or equal to x, or x is less than or equal to 22, whichever way you want to read it. So again, I'm going to draw a number line, negative infinity to infinity, and I have a 22. So x is less than or equal to the 22. So less than means we're going to go to the left. And because it has the equal to, I'm going to get a bracket. If it doesn't have a line, it's a parenthesis. But we do have the line. It means it can equal to 22. So we get a bracket there. So we have negative infinity to 22 with a bracket. And that would be our interval notation. All right, so for our next problem, we are looking to find, let me zoom in on our graph here. We are looking to find a few things about our graph here. We need to find the domain and the range. Is it a function, and why or why not? All right, so this is number 3. So on our graph here, we're looking for domain. Well, I can tell that this is a parabola and it opens up and keeps going. So for the domain, it's going to be negative infinity to infinity. For our range, it's going to come up from the bottom. So domain, you start from the left and go to the right. You go basically from the negative to the positive. And for the range, you're going from, again, the negative numbers to the positive numbers. So these are counting by ones. So we are at, for the range, we're coming up from the y value. We're at this line. This is negative 2. So it's going to go from negative 2, and it continues on up. So it'll go up to infinity. All right. And then we want to know, is it a function? Well, how do we test a function? On a graph, we can draw the vertical line, and as long as we draw a vertical line on the graph itself, like don't draw over here, but where our graphed numbers are, if I can draw one line, I can see that it will only pass the graph at one spot. So is it a function? Yes, it is. And on yours, you would actually draw a line on the exam. And we're going to say that why or why not it passes the vertical line test. And I'm okay if you put VLT. So passes vertical line test. And then our last spot would be f at -3. So we want to know when our x is equal to -3. So 1, 2, 3. What is our y value? It is actually equal to -2. So that is how we're going to find all the parts on our graph. All right, number 4. Evaluate the function of the given value and simplify. So we're plugging in -3 into our function. So we're going to say that, this is number 4, g at -3 will be equal to -3 squared plus 4 over -3 minus 5. So I'm just plugging in the value of -3 wherever the x was. So -3 squared, anytime you square any number, it's going to be positive because it's going to be itself times itself. So -3 times -3 will get us positive 9 plus 4. And -3 minus 5, they're the same sign, so we're going to add and keep the sign. And this will get us 13 over -8. Now, if it does reduce, you need to reduce it. Always simplify. All right, number 5. Number 5, this is the difference quotient, and we are finding the difference quotient. Of course, h can't be equal to 0 because that would make it undefined, of 3x minus 7. So I'm going to write what we're doing. And our f of x is equal to 3x minus 7. All right, so you can do this in multiple steps, but because this one doesn't have a square, I'm just going to plug everything in. What this first part means is instead of x, we're going to have x plus h. Like up here, instead of x, we plugged in -3. So we're going to have 3 times x plus h minus 7, that's the first part, minus our f of x. So you have to subtract the whole thing, so I'm going to put it in parentheses because you got to make sure you distribute the negative to both, all over h. So we've got 3x plus 3h minus 7 minus 3x minus a -7 will get us plus 7 all over h. Now on this, we're going to look to see if anything cancels. We have 3x and -3x and -7 plus 7. That'll leave us with 3h on our top divided by h. The h's will cancel and we're left with 3. So that's simpler than some of the examples we did in class. All right, for number 6, we are looking at a piecewise function. We need to find f at -2 and f at 3. So we have x minus 4 if x is greater than -2, and x plus 5, I'm not sure why there's parentheses there, they don't need to be there, if x is less than or equal to -2. So parentheses have no bearing there. All right, so for the first one, we need to find f at -2. So equal to -2 is what we're talking about. So it's not greater than, it's not less than, but it's equal to -2. So we're going to use the x plus 5. So that means we'll equal -2 plus 5, because we're going to plug in our x value, and it will be equal to 3. All right, and on the next part, it's asking for f at 3. So for f at 3, that is greater than -2, so we'll use the x minus 4. So for f at 3, and you don't have to put the u's, you just need to show me your work. but I want to make sure you understand what I'm doing. So we're going to plug in 3 for x this time, so we'll get 3 minus 4, and that'll be equal to -1. All right, for number 7, we're going to use the graph of the function to graph the function g and explain in words how the graph transforms or shifts. So first I'm going to do some words. So for x minus 2 plus 4, remember if it's inside the graph or inside the parentheses, we are talking about how it shifts. And I believe I'm missing an f of x equals x minus 2 plus 4. So we're just looking at the x minus 2. That goes left and right. It goes opposite of what you look at. If you see minus 2, it's actually going to go to the right. If you see plus 2, it's going to go to the left. And then the outside part means it can go up and down. So the positive 4 tells me it's going to go up. If it was negative 4, it would go down. So for this, number 7, we are going to state that it moves right 2 and it's going up 4. And then we're going to take each of those points and we're going to do exactly what we said it would do. We're going to go right 2 and up 4. So we're going to go over 2 and up 1, 2, 3, 4. 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 And then we will join our lines. So that's all you have to do there. But you have to tell me in words and then you have to show me. Okay? All right. Our next question, number 8, says determine whether the quadratic function opens up or down to determine if it has a min or max value. And then find the coordinates of the min or max point. So on these types of graphs, when we're looking at whether it opens up or down, we are looking to see if they are, if it's positive in the front or if it's negative. So if it was negative, we know with a parabola, it opens down. And if it's a positive, it's going to open up. Because at the beginning here, we don't have a negative sign. We have just a positive. We know that this is going to open up. And if it opens up, which means it looks like this. Oops, you can't see what I'm doing. Hang on. If it opens up like this, that means that bottom part is going to be a minimum. Because it's the minimum value. It's the lowest value. And on our equation, we have, with this format on part A, so we're looking at part A here, the formula for this is going to be h, k for our vertex. And it again is similar to when we were doing the transformations. It's opposite of what you see right here. So that -4 inside is actually going to be 4 because the formula is x minus h plus k. So the minus is part of the formula. So the h is going to be 4 and the k will be -9. So this is going to be the vertex. So you need to tell me it's a minimum and you need to tell me what the vertex is. Now on part B, we have a different equation here. And our different equation won't change whether it's a max or min. Again, because it's positive and it opens up, it's still a graph that looks like this. So this will still be a min. Again, if it had a negative sign, it would become a max because it would be upside down. But the formula for this one is going to be -b over 2a comma, the function at negative b over 2a. So that's the vertex formula for something like this. So we've got our x value will be equal to the negative, b is positive 4, so negative of 4 over 2, and our a is 1. So that'll get us negative 4 over 2, which will be negative 2. Now what we have to do is find the function at negative 2. So f at negative 2, we're going to plug it into our function here. So that'll be negative 2 squared plus 4 times negative 2 plus 3. So negative 2 squared will get us 4. 4 minus 2, or 4 times the negative 2 will get us negative 8, and then positive 3. And when we add those together, we will get negative 1. So that means our point will be negative 2, negative 1. So it's a minimum with a negative 2, negative 1 vertex. So two different ways of finding that vertex or that min or max. All right, let's go look at number 9. So on number 9, we have another function. We need to state the degree and find the x and y intercepts. All right, so for number 9, we are given f of x is equal to x minus 3 to the 4th times x plus 2 to the 7th. So to find the degree, we add the exponents. So we have 4 plus 7 equals 11. So that's part A. And then part B is to find the x-intercepts. And for the x-intercepts, we set y equal to 0. And then we'll also find the y-intercept where x equals 0. So on these, because it's already factored out, we can just pull x minus 3 equal to 0, the parenthesis parts, and x plus 2 equal to 0. So adding the 3 over, we'll get x equal to 3. Subtracting the 2, we'll get x equal to negative 2. So this is 3, 0. And negative 2, 0. It's really good to still write them in points so that you remember that they are a point and not an asymptote. And then for our x equal to 0, we'll have y equals 0 minus 3 to the 4th times 0 plus 2 to the 7th. So this will get us negative 3 to the 4th times 2 to the 7th power. And you can do them separately, or you can just put it in the calculator at that point. Negative 3 to the 4th will get us 81, and 2 to the 7th is 128. And if we multiply that, we'll get 10,368. So the point for this would be 0, excuse me, 10,368. So that would be our our y-intercepts, and those would be our x-intercepts. Now, on our next problem, number 10, so for number 10, we are looking at finding the vertical and horizontal asymptotes, or state that they do not exist. So we have the function f of x equals 2x minus 3 over x minus 7. So for the vertical asymptote, that's what VA stands for in this case, it is the denominator. It worries about dividing by 0. So it's very similar to finding the domain of the function. We have x minus 7 equal to 0, so x will be equal to 7. That's the vertical asymptote. For the horizontal asymptote, we are looking at matching the degree. You can do the N and M if you know what that is and you know how to find them that way. Otherwise, you're going to match the degree. These are our y equal, our highest degree on the top and the bottom. And if it was like an x squared over, then x squared would be whatever the highest degree is. Our highest degree for the whole function is x. And on the top, we have 2 x's. And on the bottom, we have 1x. Now, sometimes you'll have an x squared and then an x. X squared would still be your highest degree. So you put x squared over x squared. All right, the x's will cancel. We're left with 2. So y equals 2 is our horizontal asymptote. So match the degree, however many you have. And if you don't have like the same degree, if we had like a x squared over an x, then you would put 0 at the bottom. Or if the x squared was in the bottom, you would put 0 at the top. So you should have studied those and you should know what they are. All right, our next problem, number 11, we're solving the system. We're going to do it 2 ways. We're going to go by addition, which is elimination, or you can do substitution, and then we're going to solve it by matrices. All right, so this is number 11, and our system is x plus 2y equals 11, and 3x minus y equals 5. All right, so we got to figure out which variable we want to cancel. I think I'm going to cancel the y's. You could go for the x's. So on the y's, I need to get them to the same number, but opposite signs. They're already opposite signs, so on the top, I'm not going to change anything. And on the bottom, I'm going to multiply by a 2. So now that will get us x plus 2y equals 11, and 2 times 3x will get us 6x, 2 times negative y will get us negative 2y, and 5 times 2 will get us 10. When we add them, we get 7x, the y's will cancel, equal to 21. We'll divide by 7, and x will be equal to 3. Now that we have 3, we can plug in 3 into one of the equations. It doesn't matter which one you plug it into, but I'm going to sub x equal to 3, and I think I might just plug it into the top one. It doesn't matter. So I'll have 3 plus 2y equals 11. Subtract my 3 over, I get 2y equal to 11 minus 3 will get us 8. Divide by 2, and we get y equal to 4. So the answer is an ordered pair of 3, 4. All right, so that's using the addition or elimination. You could also do substitution, but I'm just going to do the addition one on here. And then we're going to redo the same system. So this will be 11b. Our system again was x plus 2y equals 11, and 3x minus y equals 5. Now this time we're going to do matrices. So first I have to write the matrix. So the matrix is using all of the coefficients and then the constant. So we've got 1, 2, 11, and 3, negative 1, 5. So if you recall, our goals, our first goal is to get a 1 up here. We already have a 1, so yay. Our second goal is to get 3 to become a 0. And the way to get 3 to be a 0 is to subtract 3. So to get a negative 3 to add to that, I'm going to multiply row 1 by negative 3. So negative 3 times row 1. And then I'll add that to row 2 to equal my new row 2. So for my negative 3 times row 1, I have negative 3 times 1, negative 3 times 2, and negative 3 times 11. So that'll get me negative 3, negative 6, and negative 33. And then we will add our row 2. Our row 2 is 3, negative 1, and 5. And when I add those, 3 minus 3 will get me 0. Negative 6 minus 1 will get me negative 7. And negative 33 plus 5 will get us negative 28. And now we'll rewrite our matrix. So row 1 stays the same. We didn't change it, we just used it. And 0, negative 7, negative 28 is our new row 2. Now that we have our 1 here and our 0 here, our next goal is to get this to be a 1. So negative 7 to get to a 1 means basically we need to divide by negative 7, but in matrices we don't divide. We multiply or we add. So I'm going to take 1 over negative 7 and multiply it times row 2. Because multiplying by 1 over negative 7 is basically the same thing as dividing by negative 7. So we have 1 over negative 7, or negative 1/7, it doesn't matter where you put the negative sign, times 0. Negative 1/7 times negative 7, and negative 1/7 times negative 28. So this will become 0. Negative 7 times negative 1/7 would be 1. And negative 1/7 times negative 28 will get us 4. Rewrite our matrix. So we have 1, 2, 11, 0, 1, 4. Now that we've got to this part, we can rewrite our system of equations. So we're back to writing the system. This will be x plus 2y equals 11, and y is equal to 4. Because we've solved for that y value, and then we can plug it back in. You could also do the row reduced echelon form and get this to become a 0. You can go either way you want. All right, so with y equals 4, I'm going to sub y equals 4 into our equation here. So we'll have x plus 2 times 4 equal to 11. So x plus 8 equals 11. Subtract the 8 over and get x equal to 3. And our answer is still the ordered pair of 3, 4. So we got to the same answer, which we would expect because it's the same problem. There's just different ways to do them. Be prepared to do both ways. All right. For number 12, we've got several things going on here. We have finding the cost function, revenue function, the profit function, the average cost function, the break-even point, and the compute the profit or loss corresponding to a production level of 9,000. So a manufacturer has a monthly fixed cost of $21,000 and a production cost of $7 an item. The product sells for $14 an item. So we have several things that we need to do. So this is number 12. So we need to find our cost function, and our cost function, if you recall, is going to be our fixed variable, our fixed cost plus our variable costs. So the fixed costs are $21,000 and a production cost of $7 per item. So that's going to be our variable cost. So variable cost plus our fixed cost. And it doesn't matter which order you put them in. I'm just putting it that way. All right, our next thing that we needed to find was the revenue function. And the revenue function is going to be what our product sells for. It sells for $14 an item. So this will be 14x. Our profit function is our revenue minus our cost. So this would be our revenue minus our cost function. So that's 14x minus 7x minus 21,000. So that'll equal 7x minus 21,000. And then our next function that we needed to find is the average cost function. And that is going to be our cost function all over x. So those are the different functions we were asked to find. And now we're going to find a couple of other things. The next thing it told us to find is that we need the break-even point, and then we're going to compute whether we had a profit or loss at 9,000. So for our break-even, break-even is where you break even. You don't make a profit and you don't lose any money either. So that's where our cost and our revenue equal each other. So this will be our C of x equals to our R of x, or you can say the R of x equals C of x. It doesn't matter. All right, so for that break even, our cost function is 7x plus 21,000, and it's equal to our 14x, which is our revenue function. So I'm going to put all the x's on one side, and we'll have 21,000 is equal to 7x, divide by 7, and we get x is equal to 3,000. So that means that our break even is when we sell 3,000 products, we're going to make $0. We're going to make 0. So that is our point. That's the break-even point. All right, and then the next thing it asked us to find was the profit or loss at 9,000. So that means we're going to use our profit function right here. And let me box this so that you can tell which one we're using, because we've already solved down for it. So our P of x at 9,000. So for the profit or loss, we'll take our P at 9,000. So that's going to be 7 times 9,000 minus 21,000. 7 times 9,000 will get us 63,000 minus 21,000 will get us 42,000. And because it's a positive number, it will be a profit. Okay? So there were several things to do on there. We just have to work each one at a time. All right, our next problem, we are doing some manufacturing. They found the profit in dollars is P of x equal to this. We need to find the unit price that generates the maximum profit, and then find the maximum profit to the nearest dollar. All right, so if we're talking about minimum or maximum, we are talking about the vertex again. So for number 13, we are given P of x is equal to negative 2x squared plus 540x. We want to find the price that generates the maximum profit. So that means we need to find the x value, and then the maximum profit to the nearest whole dollar will be our y value. So if you recall, because this is an x squared plus an x, this is going to be negative b over 2a, just like we did on a previous problem. So negative b will be negative 540. We just don't have a c on this, but we have the a and the b, so it's okay. And then we have 2 times negative 2 for our a. This will get us negative 540 over negative 4, and that'll be 135. So that is the unit price is $1.35. So now we need to find the profit at $1.35 will be -2 times 135 squared plus 540 times 135. And you can just put that in the calculator and you'll get 36,450. So if we sell our product for the unit price of 135, we will make a profit, the maximum profit will be 36,450. So that'll be our max profit. All right, we have one more problem. All right, so on this one, solve using systems of equations. So that means this one didn't give us the system like we did earlier. You're going to have to make the system. The Metropolitan Theater is selling tickets for a premiere opening of a play. They charge 14 for adults, 9 for children. A total of 486 tickets have been sold, totaling 5,104. So how many adult tickets and children tickets were sold? Well, to do this one, you're going to take the adult plus the children will equal a total. You can pick any variable you want. Most students really like X and Y, so that's what I usually use. So we have a total of 486 tickets were sold in our problem. So our adult plus children equal 486. And then we were told that the price of the adult tickets was 14, and the price of the child tickets are $9. And we had a total profit of 5,104. So we're just pulling the numbers out. We had a total of 486 tickets. The charge was 14 for adults, 9 for children, for a total of 5,104. So whatever's going on with the adult plus the children equal the total. Now, you can solve this multiple ways. I'm going to use the addition method. So what I'm going to do here is I'm going to multiply the top equation. It's easier for me if I eliminate the y's, because then I don't end up with a bunch of negative numbers that I have to deal with at the end. So I'm going to multiply by -9 on the top and no change on the bottom. And you don't have to necessarily draw the arrows. I just find that my students are able to follow along a little bit better. All right, so this will be -9x minus 9y, and -9 times 486 will get us -4374. And then no change, we have 14x plus 9y equals 5,104. When we add these, we get 5x equal to 730. Divide by 5, and x equals 146. So we found how many adult tickets there are, because that's the 146. And now what we'll do is sub x equals to 146 into our x plus y. 146 plus y equals 486. Subtract it over, and y equals 340. So we have 146 adult tickets, and we have 340 children tickets. And even though we're solving as a system of equations, the x and the y won't necessarily tell you what you've done, so that's why we're going to write out what adult and children tickets look like. So that's basically the types of problems we have been solving, and you need to be studying away and work your bonus review so that you can make sure you are prepared for the exam.